Hello my dear student. Last class we discussed about the various properties of colloidal solution. In this class we will be discussing about the coagulation or precipitation or flocculation. So here in colloidal system, the colloidal particles are charged. The colloidal particles are charged either positive, either negative, either positive, either negative. Due to this, the colloidal system is stable. However, the charge on colloidal particles is neutralized by adding electrolyte. Here, the colloidal particles are joined together to grow bigger size and finally precipitate out. This process is known as coagulation, precipitation, or flocculation. So here, in colloidal system, the colloidal particles are either positively charged or negatively charged. Due to this, the colloidal system is stable. However, the charge on colloidal particle is neutralized by adding electrolyte. So here, after adding electrolyte, the colloidal particles are joined together, grow bigger size, and finally precipitate out. This process is known as coagulation. So here, the exact definition of coagulation is the phenomenon in which precipitation of colloidal solution by using excess of electrolyte. This is called as coagulation. So here, the phenomenon in which precipitation of colloidal solution by adding excess of electrolyte. This is called as coagulation. So note, colloidal system ಒಳಗೆ colloidal particles ಏನಾಗಿರ್ತವೆ, ಪಾಸಿಟಿವ್ ಮತ್ತು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಹೊಂದಿರ್ತಾವೆ. ಸೊ ಪಾಸಿಟಿವ್ ಮತ್ತು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಹೊಂದಿರೋದ್ರಿಂದ colloidal system ಏನಾಗಿರುತ್ತೆ ನಮಗೆ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. ಹೌದಾ? ಇದಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೇವೆ ಅಂತಂದ್ರೆ electrolyte add ಮಾಡ್ತೇವೆ. ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ electrolyte ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ Na+ Cl-. Na+ add ಮಾಡಿದ್ರು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ colloidal particles accumulation ಆಗುತ್ತೆ. Cl- ಅಂತ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ colloidal particles ಗೆ accumulation ಆಗುತ್ತೆ. ಹೌದಾ? ಏನಾಗುತ್ತೆ, ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಆಯ್ತು ಅಂತಂದ್ರೆ colloidal particles ಏನು ಮಾಡ್ತಾವೆ, ಒಂದೊಂದು ಕೂಡ್ತಾವೆ. ಹೌದಾ? ಕೂಡಿ ದೊಡ್ಡ ಸೈಜ್ ಆಗ್ತವೆ. ದೊಡ್ಡ ಸೈಜ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಗ್ತವೆ. ಫೈನಲ್ ಗೆ ಸೇರಿ precipitate ಸಿಗುತ್ತೆ. ಇಂಥ process ನ ಏನು ಕರೀತೀವಿ ಅಂದ್ರೆ coagulation, precipitation or flocculation. Okay, exact definition ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ phenomena in which precipitation of colloidal solution by using excess of electrolyte. This is called as coagulation. Arsenic sulfide soap. So here the colloidal particles are negatively charged. Adding electrolyte such as NaCl. So here the positive part of the electrolyte neutralize the negative part of the colloidal solution. So here the colloidal particles are joined together, grow in bigger size, and finally precipitate out. So here Na+ ion is the positive part of the electrolyte. It is responsible for coagulation. Therefore, this positive part of electrolyte is known as active ion. Or flocculating ion. So note, example I want to arsenic sulfide solution example ತಗೊಂಡ್ರೆ ಗೊತ್ತಾ, ಈ arsenic sulfide solution ಒಳಗ ಏನೈತಿ, colloidal particles are negatively charged. ಹೌದಾ? ನಾವು ಏನು ಆಡ್ ಮಾಡ್ತೀವಿ, electrolyte. ಯಾವ electrolyte ಆಡ್ ಮಾಡ್ತೀವಿ, sodium chloride. So here in this sodium chloride containing positive charge ion. This positive charge ion neutralize the negative charge colloidal solution. This positive charge of electrolyte neutralize the negative charge colloidal solution. ಏನಾಗುತ್ತೆ positively charged ions negatively charged colloidal particles ಏನು ಮಾಡುತ್ತೆ ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡುತ್ತೆ ಹೌದಾ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ colloidal particles ಎಲ್ಲ ಏನು ಮಾಡ್ತಾವು ಜಾಯಿಂಟ್ ಟುಗೆದರ್ ಆಗ್ತಾವು ಕೂಡ್ತಾವು. ಅವಾಗ ನಮಗೆ ಫಾರ್ಮೇಷನ್ ಆಗ್ತೈತಿ ಬಿಗ್ಗರ್ ಸೈಜ್ particles formation ಆಗುತ್ತೆ ಹೌದಾ. ಫೈನಲ್ ಏನು ಸಿಗುತ್ತೆ ಪ್ರಿಸಿಪಿಟೇಟ್ ಸಿಗುತ್ತೆ. ಇಲ್ಲಿ ಕೋಗುಲೇಷನ್ ಯಾವ ಹೆಲ್ಪ್ ಆಗಿ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಸೋಡಿಯಂ ಪ್ಲಸ್ ಅಂದ್ರೆ ದ ಪಾಸಿಟಿವ್ ಪಾರ್ಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಏನು ಮಾಡಿದ್ವಿ ಕೋಗುಲೇಷನ್ ಗೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಏನು ಕರಿತೀವಿ ಆಕ್ಟಿವ್ ಅಯಾನ್ಸ್ ಅಂತ ಏನು ಕರಿತೀವಿ ಆಕ್ಟಿವ್ ಅಯಾನ್. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದಿ coagulation or precipitation and flocculation. So next we move towards coagulation of lyophobic solutions. So here already we know what is lyophobic solutions. So here there are number of methods are used for the coagulation of lyophobic solutions. So first one is by mixing of two oppositely charged colloidal solution. First one, mixing of two oppositely charged colloidal solution. So here, when oppositely charged colloidal solutions are mixed almost equal proportion. Oppositely charged colloidal solutions are mixed almost in equal proportion. Neutralize their charges and get partially and completely precipitate. So here, oppositely charged colloidal solutions are mixed in almost equal proportions. Neutralize their charges and get partially and completely precipitated. So consider example, the negatively charged colloidal solution of arsenic sulfide is mixed with positively charged colloidal solution of hydrated ferric oxide. Combination of these two colloidal solutions of opposite charges we get coagulation or precipitation. This coagulation or this precipitation is known as mutual coagulation. Mutual coagulation. So first one, by mixing of two oppositely charged colloidal solution. ಏನು ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ oppositely charged colloidal solution mix ಮಾಡ್ತೀವಿ. ಹೆಂಗೆ mix ಮಾಡ್ತೀವಿ ಅದು ಹೆಂಗಿರಬೇಕು ಅಂತಂದ್ರೆ ಆಲ್ಮೋಸ್ಟ್ ಈಕ್ವಲ್ ಪ್ರಪೋರ್ಷನ್ಸ್ ಆಗಿರಬೇಕು. ಆ ಎರಡು opposite charged colloidal solution mix ಮಾಡ್ತೀವಿ. ಸೊ ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತೈತಿ ಅಲ್ಲಿ ಚಾರ್ಜಸ್ ಏನು ಮಾಡ್ತೀವಿ ನ್ಯೂಟ್ರಲೈಸ್ ಆಗ್ತದೆ ಹೌದಾ. ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಪಾಸಿಟಿವ್ colloidal particles ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ನೆಗೆಟಿವ್ colloidal particles ಏನು ಮಾಡ್ತೀವಿ ಮಿಕ್ಸ್ ಆಗ್ತದೆ ಹೌದಾ. ಏನಾಗೈತಿ neutralize their charges and get completely and partially precipitated. Okay, example ಏನು ತಗೊಂಡಿವು negatively charged colloidal solution of arsenic sulfide is mixed with positively charged solution of hydrated ferric oxide. So here mixing of these two we get coagulation. This type of coagulation is known as mutual coagulation. Okay, so next is by boil. So here when the solution is boiled, adsorption layer is disturbed due to increased collision with molecules of dispersion medium and reduce their charges or neutralize their charges and finally precipitate out. So here consider when solution is boiled, adsorbed layer get disturbed due to increased collision with molecules of dispersion medium and reduce their charges or neutralize their charges and finally precipitate out. So this is the second method for the coagulation of lyophobic solution. Second method ಯಾವುದು ರೀತಿ ಬಾಯ್ಲ್. ಸೊ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಸೊಲ್ಯೂಷನ್ ನ ಬಾಯ್ಲ್ ಮಾಡ್ತೀವಿ. ಸೊಲ್ಯೂಷನ್ ಬಾಯ್ಲ್ ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ ಅಡ್ಸಾರ್ಬ್ ಏನಾಗುತ್ತೆ ಡಿಸ್ಟರ್ಬ್ ಆಗುತ್ತೆ. ಓಕೆ ಅಡ್ಸಾರ್ಬ್ ಹೆಂಗ್ ಡಿಸ್ಟರ್ಬ್ ಆಗತ್ತಪ್ಪ ಅಂದ್ರೆ ಕೊಲಿಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಕೊಲಿಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಅಡ್ಸಾರ್ಬ್ ಲೇಯರ್ ಮತ್ತು ಮೊಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಇರತಕ್ಕಂತ ಪಾರ್ಟಿಕಲ್ಸ್ ಕೊಲಾಯ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನ್ ಮಾಡತ್ತೆ ಕೊಲಿಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಕೊಲಿಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಯಿತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಆಗುತ್ತೆ. ಹೌದಾ ಅಂದ್ರೆ ಚಾರ್ಜ್ ಆಫ್ ಕೊಲಾಯ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇಸ್ ಡಿಕ್ರೀಸ್. ಓಕೆ ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ precipitate formation. Okay, this is the second method by boil. Third one by persistent dialysis. Persistent dialysis. So here on prolonged dialysis, the trace amount of electrolyte present in solution can be removed, but the colloidal particles becomes unstable, ultimately coagulated, we get precipitate. So here on prolonged dialysis, trace amount of electrolyte can be removed. So here the colloidal becomes unstable. Ultimately, they coagulate. We get precipitate. So, third one by persistent dialysis. On prolonged dialysis continue ಮಾಡಿ. Okay, ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ dialysis ಅಂದ್ರೆ ಏನು ಅಂತ ಹೇಳಿ. Okay, so ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಕಂಟಿನ್ಯೂಸ್ ಡಯಾಲಿಸಿಸ್ ಮಾಡೋದ್ರಿಂದ ನಾವು ಏನು ಮಾಡಕತ್ತೀವಿ ಎಲ್ಲ ಅಂದ್ರೆ ಟ್ರೇಸ್ ಅಮೌಂಟ್ ಆಫ್ all electrolytes are removed almost completely. ಹೌದಾ ಎಲ್ಲ electrolyte ಹೊರ ತೆಗೆದುಕೊಂಡ್ರೆ ಒಳಗೆ ಬಿಟ್ಟು ನಮಗೆ ಓನ್ಲಿ colloidal particle ಉಳಿತು. ಬಟ್ colloidal particles ಹೆಂಗೆ ಅದಾವು ಅನ್ಸ್ಟೇಬಲ್. ಸೊ ಅನ್ಸ್ಟೇಬಲ್ ಆಗಿರೋದು ನಾವು ಮಾಡೋದು ಬಂದು ಮಾಡೋದು ಜಾಯಿನ್. ಓಕೆ ಸೊ ಜಾಯಿನ್ ಟುಗೆದರ್ ಟು ಫಾರ್ಮ್ coagulation. So here third one is by persistent dialysis. So here on prolonged dialysis the trace amount of electrolyte present in solution can be removed completely. The colloidal particles are unstable. They join together to form coagulation. This is the fourth one by electrophoresis. So already we know what do you mean by electrophoresis. The movement of colloidal particle in an applied electric field that is known as electrophoresis. So here the colloidal particles are moved towards the opposite charge electron and discharge we get precipitate. So here the colloidal particles are moved towards the opposite charge electron and get discharged and finally precipitate. So here this is the by electrolyte. So here the electrolyte is added to colloidal solution. The colloidal particles precipitated. So here the colloidal particles are interact with oppositely charged ions, cause neutralization and form coagulation. So here adding electrolyte into the colloidal solution we get precipitate. Adding electrolyte into the colloidal solution, the colloid becomes precipitate. So here the colloidal particles are interact with oppositely charged ions. Colloidal particles are interact with oppositely charged ions, causes neutralization and form precipitate. So again ಮಾಡಕತ್ತೀವಿ electrolyte ನ colloidal solution ನ HCl ಮಾಡಕತ್ತೀವಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ colloidal solution ನ precipitate formation ಮಾಡ್ತೀವಿ. ಹೆಂಗ್ precipitate formation ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ colloidal particles ಏನು ಮಾಡ್ತಾವು interact ಆಗ್ತಾವು. ಜೊತೆಗೆ interact ಆಗ್ತಾವು opposite charge ion ಜೊತೆಗೆ interact ಆಗುತ್ತೆ. So interact ಆಯ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಆಗುತ್ತೆ. ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಆಯ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, colloid particles ಎಲ್ಲ ಒಂದ್ ಕಡೆ ಬರ್ತಾವೆ, ಅವರ ಮೇನ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ, precipitate formation ಆಗುತ್ತೆ. Okay, so here the ions which is responsible for coagulation, that ions is known as active ion or flocculation ions. The ions which are responsible for coagulation, that ions is called as active ion or flocculation ions. So here this is about the by addition of electrolyte. So these are the method used for coagulation of lyophobic solution. So next we move towards the Herding and Scotch rule. So here the higher the valency of active ion, higher the valency of active ion, greater is its precipitation power. So this is known as Herding and Scotch rule. So here the higher the valency of active ion of flocculation ion, greater is its precipitation power. This rule is known as Herding and Scotch rule. So now ये कुल बदलता हूँ active ion या active ion के valency जास्ती रहती है, अदेन मानते जास्ती precipitation formation मार्जिन करता है. So this is the Herding and Scotch rule. So for example, the coagulation of negative ions, the coagulation of negative solutions, the coagulation of negative solution, the order of flocculation ions, the order of flocculation ions is Al plus 3 is greater than Bl plus 2 is greater than Na plus. So here the coagulation of negative solution, the order of flocculation ions are Al plus 3 is greater than Bl plus 2, Bl plus 2 is greater than Na plus. So here consider an example, coagulation of arsenic sulfide, coagulation of arsenic sulfide. So here the efficiency of some cation ions are in the order Al plus 3 is greater than Bl plus 2, Bl plus 2 is greater than Na plus. It indicates, so in this case Al plus 3 when it is added with arsenic sulfide solution, it gives higher precipitate, because in this case Al plus 3 having higher valency as compared to Bl plus 2 and Na plus. So here according to this rule, the higher valency of active ion or flocculation ion, greater in its precipitating power. Okay, so now another example, the coagulation of positive solution, the coagulation of positive solution, the flocculation ions orders are Cl is greater than PO4 minus 3 is greater than SO4 minus 2 is greater than Br minus. So here consider an example, coagulation of ferric hydroxide solution, coagulation of ferric hydroxide solution. So this is a positive solution, positive or positively charged coagulation of ferric hydroxide solution. The order of some ions are, so here efficient 6 is greater than PO4 minus 3, it is greater than SO4 minus 2 and it is greater than Br minus. So here when this ferric hydroxide is treated with efficient 6, it gives higher precipitate because it having higher valency. So therefore according to this rule, the higher valency of active ion or flocculation ion, greater is its precipitating power. This is known as Herding Scotch rule. So next we move towards coagulating value. So here the minimum concentration of electrolyte, minimum concentration of electrolyte in millimoles per liter, millimoles per liter required to cause precipitation, requires to cause precipitation of solution, required to cause precipitation of solution in 2 hours is called as coagulating value. The minimum concentration of electrolyte in millimoles per liter required to cause precipitation of solution in 2 hours. So this is called as coagulating value. So what do you mean by coagulating value? The minimum concentration of an electrolyte in millimoles per liter required to cause precipitation of solution in 2 hours. So this is called as coagulating value. So next we move towards coagulation of lyophilic solution. So here there are 2 factors are responsible for stability of lyophilic solution. There are 2 factors responsible for stability of lyophilic solution. The first one is charge and second one is solvation of colloidal particles. So here, when these 2 factors are removed, the lyophilic solution can be coagulated. So here, these 2 factors can be removed by 2 methods. So first one is by addition of electrolyte and second one by addition of suitable salt. So here these are the 2 methods for the removal of 2 factors. First one is charge and second one solution of colloidal particle. So usually acetone or alcohol is used for suitable solvent. When acetone and alcohol is added into hydrophilic solution, the dehydration of dispersion phase take place. At this time, the small amount of electrolyte can be coagulated of lyophilic solution. So here, usually alcohol and acetone is used as a solvent. When we add alcohol or acetone into the hydrophilic solution, the dehydration of dispersal phase take place. At this stage, only small amount of electrolyte is needed for coagulation of lyophilic solution. Coagulation of lyophilic solution. ಹೌದಾ? ಸೊ ನೋಡಿ, 2 ಫ್ಯಾಕ್ಟರ್ ಏನು ಮಾಡ್ತಾವೆ? ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ lyophilic solution ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಮಾಡ್ತಾವೆ. ಯಾವ ಫ್ಯಾಕ್ಟರ್? ಒಂದನೇದು ಚಾರ್ಜ್, ಎರಡನೇದು ಫಾರ್ಮೇಷನ್ ಆಫ್ colloidal particle. ಸೊ ಈ 2 ಫ್ಯಾಕ್ಟರ್ಸ್ ನ ರಿಮೂವ್ ಮಾಡಿದ್ವು ಅಂತಂದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ? lyophilic solution should be colloidal formation ಆಗುತ್ತೆ. ಹೌದಾ? ಈ 2 ಫ್ಯಾಕ್ಟರ್ ಹೆಂಗೆ ತೆಗಿಬಹುದು ಅಂದ್ರೆ by using 2 ಮೆಥಡ್. ಒಂದನೇದು addition of electrolyte, ಇನ್ನೊಂದು addition of suitable solvent. ಯೂಶುವಲಿ ನಾವು ಆಲ್ಕೋಹಾಲ್ ಮತ್ತು ಎಸಿಟೋನ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ನೋಡಿ, ಆಲ್ಕೋಹಾಲ್ ಮತ್ತು ಎಸಿಟೋನ್ ಅನ್ನು ನಾವು ಹೈಡ್ರೋಫಿಲಿಕ್ ಸೊಲ್ಯೂಷನ್ ಹಾಕಿದ ಕೂಡಲೇ ಅಲ್ಲಿ ಏನಾಗ್ತೈತಿ? ಡಿಹೈಡ್ರೇಷನ್ ಆಗುತ್ತೆ, ವಾಟರ್ ರಿಮೂವ್ ಆಗುತ್ತೆ. ಎಲ್ಲಿಂದ ಆಗ್ತೈತಿ? ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಇರ್ತಕ್ಕಂಥ ವಾಟರ್ ರಿಮೂವ್ ಆಗ್ತೈತಿ. ಸೊ ಅವಾಗ ಏನಾಗ್ತೈತಿ? ನಾವು ಇವನ್ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಡಿಷನ್ ಮಾಡಿದ್ರು ಅವಾಗ coagulation formation occur. So this is about the coagulation of lyophilic solutions. So next we move towards the production of colloids. So here lyophilic colloid solutions are lyophilic solutions are more stable than lyophobic solution. So here lyophilic solutions are more stable than lyophobic solution because the lyophilic colloidal particles are extensively hydrated. So here the lyophilic solutions are more stable than lyophobic solution because lyophilic colloidal particles are extensively hydrated. So here the lyophilic solutions are unique property to protect the lyophobic colloidal particle. When we add lyophilic solution into the lyophobic solution, the lyophilic particles forms layer around the lyophobic solution. So here when we add lyophilic solution into lyophobic solution, the lyophilic colloidal particles forms layer around the lyophobic solution, prevent from electrolyte. So here this is a unique property of lyophilic solution. Therefore this lyophilic solution is also known as protective colloids. This lyophilic solution is also known as protective colloids. So here lyophilic solutions are more stable than lyophobic solutions because the lyophilic colloidal particles are extensively hydrated. So here lyophilic solutions are unique property to protect the lyophobic solutions. When we add lyophilic solution into lyophobic solution, the lyophilic colloidal particles are forms layer around the lyophobic solution to prevent from electrolyte. So therefore the lyophilic solutions have unique property to protect the lyophilic solution. Therefore this lyophilic solution is also known as protective colloidal solution or protective solution. So here this is about the production of colloids. So next we move towards the colloids around us. First one is food materials. So here milk, butter, ice cream and fruit juice etc. These all are in colloidal form. Second one, soil. So here fertile soil, it is in colloidal form in which humus act as protective colloids. On account of colloidal nature, it absorbs moisture. So here the fertile soil, it is in colloidal nature in which humus act as protective colloids. On account of its colloidal nature, it absorbs moisture. So here this is about the second one, soil. Third one, blood. So here blood, it is the colloidal form of albinoid. Blood, it is the colloidal form of albinoid. So here alum and ferric chloride exhibit septic action because coagulation of blood forming clot by alum and ferric chloride. So here third one is blood. Blood, it is the coagulation of albinoid, alum and ferric chloride, exhibit septic action because coagulation of blood forming clot by alum and ferric chloride. Fourth one, the formation of dust. So here the rivers containing negatively charged sand and clay particles at the point where river meet sea. The sea containing electrolyte such as sodium, potassium, magnesium, etc. They are coagulation with negatively charged sand and clay particle. This region is called as dirt. So fourth one is formation of dirt. So here the river containing negatively charged sand and clay particles at the point where river meets sea. The sea containing electrolyte like sodium, potassium, magnesium, etc. They are coagulation of negatively charged clay and sand particles. That region is called as formation of dirt. Fifth one, blue color of sky. So here the dust particle along with water suspended in air scatters blue light reaches to our eyes. The sky look blue to us. So this is about the colloids around us. So next we move towards the application of colloids. So first one, purification of colloids. So here muddy water containing negative charge colloid. By adding small amount of potash alum, which furnish Al+3 ions. These ions are coagulated with clay particles. Then the clay particles are settled down. The upper water clear. So here the muddy water containing negatively charged colloids. By addition of small amount of potash alum, which furnish Al+3 ion, this coagulation with colloidal particles of clay. Then the clay particles are settled down. The water means the upper water is clear. So this is the first application, purification of water. So ಏನು ಮಾಡ್ತೀವಿ, ಮಡ್ಡಿ ವಾಟರ್ ಅಂದ್ರೆ ಕಲುಷಿತವಾಗಿರ್ತಕ್ಕಂಥ ವಾಟರ್ ಏನು ಮಾಡ್ತೀವಿ, ಪೊಟ್ಯಾಶ್ ಅಲಮನ್ನ ಹಾಕ್ತೀವಿ. ಪೊಟ್ಯಾಶ್ ಅಲಮ್ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಸ್ಫಟಿಕ, ಅದನ್ನ ಹಾಕಿದ್ರೆ ಏನಾಗೈತಿ, ಪೊಟ್ಯಾಶ್ ಅಲಮ್ ಇಂದ Al+3 ಪಡ್ಕೊಡ್ತೈತಿ. ಸೊ ಈ Al+3 ಮಾಡೈತಿ ಕ್ಲಿಯರ್ ಆಗಿರ್ತಕ್ಕಂಥ ಕೊಲಾಯ್ಡ್ ಪಾರ್ಟಿಕಲ್ ಜೊತೆ ಕಾಂಬಿನೇಷನ್ ಆಗಿ ಕೋಲೇಷನ್ ಫಾರ್ಮೇಷನ್ ಆಗಿ ಅಂದ್ರೆ ಪ್ರಿಸಿಪಿಟ್ ಫಾರ್ಮೇಷನ್ ಆಗೈತಿ. ಸೊ ಈ ಪ್ರಿಸಿಪಿಟ್ ಕೆಳಗೆ ಸೊ ಮ್ಯಾಗಿ ಲೇಯರ್ ಏನಿದೆ clear. Second one, medicines. So here the most of the medicines used in colloidal form because they are more effective due to large surface area. So ನೋಡಿ, most of the medicine ಏನು ಮಾಡ್ತೀವಿ, colloidal form ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಯಾಕಪ್ಪ ಅಂತಂದ್ರೆ ಇಫೆಕ್ಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾಕೆ ಇಫೆಕ್ಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಅದರ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಅದರ ಇಫೆಕ್ಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀವಿ, ಮೆಡಿಸಿನ್ colloidal form ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, colloidal gold solution is used intramolecular injection. Colloidal gold solution is used intramolecular injection. Okay. So next, third one, in photography, the colloidal solutions of silver bromide, in gelatine is applied on glass plate or paper to form sensitive plates in photography. So here the colloidal solution of silver bromide in gelatine is applied on plate or paper to form sensitive photographic plate. So next, fourth one, in industry. So here paints, cement and fabric plastics, these all are colloidal in nature. And fifth one, in rubber industry. So here rubber can be prepared by coagulation of latex with formic acid. So here these are the applications of colloidal solution. First one is purification of water. So here muddy waters are negatively charged colloid by adding little amount of potash alum, which furnish L+3 ions, which cause coagulation with the particles of clay, and the clay particles are settled down, the upper water cleared. Second one, medicines. So here the medicines are used in colloidal form because they are more effective due to large surface area. For example, colloidal gold solution is used intramolecular injection. So next, third one, photography. So here the colloidal solution of silver bromide in gelatine is applied on a plate or paper to form sensitive plates for photography. So next for industry. So here paints, plastics, inks, rubbers are all in colloidal nature. Last one, rubber industry. So here the rubber can be formed by coagulation of latex with formic acid. So here this is about the application of colloids, and it completes your surface chemistry. If you have any doubts, contact me. Thank you.